So in the previous video, we talked about density and we learned how to calculate density. If you know the mass and you know the volume, mass divided by volume, you get the density. What if you're given the density already and you are given maybe the mass and you're asked to find the volume? Or what if you're given the density and given the volume and asked to find the mass? Well, you know that the formula is D is equal to M over V. So a lot of people will just plug and chug, manipulate the equation, and solve for the unknown. What I really like to do is use density as a conversion factor because I love the concept of canceling units. So let's go ahead and do two problems, and then your book has a ton more. These I actually got from the back of chapter 2 in your book. So it says that the density of milk is 1.03 grams per milliliter, because remember, density always has 2 units, grams per milliliter. How much does 1 cup, a cup happens to be 236 milliliters. So we want to know how much does a cup of milk weigh in grams. All right, so how do you do something like that? You don't start off with density. You leave density alone and you start off with either the mass or the volume. So they gave us the volume. So we're going to write down 236 milliliters. Now we're going to use density as a conversion factor. Remember, conversion factors are all about canceling units. So what unit do we want to cancel and what unit do we want to end up with? Well, it says here that they want you to get the weight in grams. So we want to end up with grams. The unit that is given to us is milliliters. So we're looking at density. Density is 1.03 grams per, it'll help you, 1 milliliter. Because a lot of students have a really hard time with nothing being underneath. Think of it as a ratio, 1.03 grams per 1 milliliter. All right, good. So now we have some numbers. What unit do we want to cancel? We want to cancel milliliters, so we put milliliters over here because that's what we learned in dimensional analysis. Grams over here. We look at the numbers associated with the density, 1.03 grams per 1 milliliter. Okay, now milliliters cancel. Look how beautiful dimensional analysis is. It helps us solve this problem. We then pick up our calculators and we have 200, if I can turn this on, 236 times 1.03. And it says here, my calculator says 243.08. That's 5 sig figs. I can only have 3 sig figs here because this is 3 and this is 3. So my final answer is going to be 243 grams. Okay? Down here is another problem. Oh, I was about to say, do you guys know what this element is? You should know your elements by now. This is nickel, okay? Nickel metal has a density of 8.90 grams per centimeter cubed. Remember, a centimeter cubed is the same as a milliliter. It's just that it's used more typically with solids in science. So 8.90 grams per centimeter cubed. How much does 15 centimeter cubed of nickel weigh in grams? So I'm going to erase this one over here and do that problem up here. All right. Okay. So they gave us the density and they gave us the, what is this? 15 centimeter cubed. It's volume. Okay. Because remember when we said length times width times height, centimeters times centimeters times centimeters, centimeter cubed. All right. How much does 15 centimeters cubed of nickel weigh in grams? You never start with the density, you start with either the volume or the mass. So in the last problem, we started with the mass. This one, we're going to start with the volume. So we'll write 15 centimeter cubed. And then they want you to get your mass in grams. I'm going to put grams over here. Okay. All right. 8.90 grams, centimeter cubed. All right. What are we going to cancel? We want to cancel centimeter cubed. And then grams is over here. Oh, we gave you I want it a different problem. This is still the same thing. Gave you volume, you have to find the mass. And the other one that we did earlier was also volume, find the mass. I'm going to have to find one where I give you the mass and you have to find the volume, but that's fine. All right, so we take 8.90 grams and we put that over here. What do we put over here? 1. Remember, because all these densities are this many grams per 1 ml or per 1 centimeter cube. All right, so the centimeters cubed cancel, and then you just multiply 15 by 8.90. So get your calculator, 15 times 8.90, and I end up with 133.5 as my answer. 133.5 grams. Is that okay? Am I allowed to have that many sig figs? Am I? No. Why not? Because this is only 2 sig figs and this is 3 sig figs. So I need to bring this down to only 2 sig figs. The best way to do that is to first turn it into scientific notation. So I'm going to take this number, turn it into scientific notation. So move the decimal 1, 2 spots. So you've got 1.335 times 10 to the second grams. Now I can drop any digits to the right of the decimal because I've accounted for the spot of the decimal using my exponent. So I'm going to drop these two guys. This is not a 5 or higher, so I stay. So your final answer would be 1.3 times 10 to the second grams. Or you can write 130 grams. That's also okay. These are identical. This is 2 sig figs. This is 2 sig figs. This means 130. This also means 130. Everybody okay with that? All right, so now let me do a problem where I give you the mass and you need to find the volume. All right, let me see if I can find one in your book. If not, I'll just make one up. No problem. Let's see here. Okay. Let's say I have a liquid. This liquid is 2.0 grams. That's the mass of the liquid. And the density of the liquid, oh, I'm looking at the wrong thing. Oh, sorry, guys. Okay, let me do the gasoline one. This is good. So I have gasoline is 75.0 grams of gasoline. And I know that the density of gasoline is 0.56 grams per milliliter. Just quick question for you guys. Is this going to float? Is gasoline going to float on water or sink? Remember how we said that if the density is less than the density of water is 1. Since this is less than water, it's going to float. If it was more than water, it would sink. Okay, so I have the mass and I have the density, and the question is, what is the volume in milliliters? All right, remember what I told you guys. Don't ever start with the density. Start with either the volume or the mass. So I'm starting off with the mass, 75.0 grams. I'm going to use density as a conversion factor, and I want milliliters. Make your life easier, draw a big line and say per 1 milliliter. All right, now what are we going to do? To cancel grams, you need to have grams down here. To end up with milliliters, you need to have milliliters up here. So basically what you're doing in this one is flipping the density. Just literally flip it. So we put 0.56 over here and 1 milliliter over there. Make sense? And then that way you go 75 divided by 0.56. Let's do it. 75 divided by 0.56. You get my glasses. Such an old calculator. I end up with 1,000 133.9285714. Big, big number in your calculator. How many sig figs do I need to, let me just write out the number so that you can decide with me. It's 133.9285714. That's what I got when I did 75 divided by 0.56. Am I allowed to put that whole number? No, because we've learned sig fig rules. This is a measured number, this is a measured number. This is 3 sig figs, this is 2 sig figs. So this final answer has to be 2 sig figs. You cannot leave it like this. So best way to figure this out, convert it to scientific notation. So know that this is the number, so I'm going to convert it to scientific notation, move it 2 decimal places. 1.3392855714 times 10 to the second. Great. Now I can drop any numbers I want to the right of the decimal. No problem. All right. I only want 2 sig figs, so that means I got to drop all these guys. These are the 2 ones that I want to keep. This is not a 5 or higher, so I stay. So my final answer is 1.3 times 10 to the second milliliters. Or you can write 130 milliliters. 2 sig figs, 2 sig figs. Okay? Okay, I think that is it for density. Our last video for this what you need to know list will be about temperature, and then I'll see if there were any other issues that I had forgotten in this chapter. I'll add them into that last video. Okay.